for cross-sectional data, we have X1. These are not time dependent. X1, it can stand for, say, height of students. Height 1, height 2, height 3 of the third student, the height of the fourth student, up to the height of the nth student. So basically, that gives us the difference between those two types of data. Now, we also have the panel or longitudinal data. The panel or the longitudinal data. The panel or longitudinal data, here observations on different cross-sections over time. So it combines both the cross-sectional data and the time series data. So that's basically what the panel data is, or the longitudinal data. You have combination of both the cross-sectional data and the time series data. Example, annual malaria mortality rate of different states in Nigeria between 2015 to 2024. Where is the cross-sectional part there and where is the time series part there? Somebody should help us identify. Remember, we said longitudinal combines both cross-sectional and time series. So who wants to help us identify the two aspects in this particular example? You want to help us? Bring the mic. She wants to give it a try. Longitudinal combines both cross-sectional and time series. Okay.
Okay. Cross-sectional because it is in different states.
Okay.
In Nigeria.
Yes.
The time series because it has to do with the time.
A wide range of time. Thank you very much. Between 2015 and 2024. Thank you. Yearly sales of 10 companies over 10 years. Another person from this side should help us. Yes.
Now, because it involves 10 different companies.
Okay.
And then it is time series because it occurs over a period of 10
years. Over 10 years. Thank you very much. So longitudinal combines both cross-section and time series. Daily maximum temperature of 5 towns in Benue State over a year. It can be a monthly for a year. So that's that for 5 towns. Now, what are the steps in time series analysis? What steps we want to carry out is time series analysis. What steps do we follow? How do we carry out time series analysis? And time series analysis is quite important. There is, over time, in time past, man has been looking for ways. We want to know what tomorrow holds. What does tomorrow holds? And that's why many people have gone to, they've consulted soothsayers. Some have gone to prophets. Some of us have visited CS to tell us what tomorrow is. Is it not? We want to know, man is eager to know what tomorrow holds. We always striving. We want to know what, and because it will help us. You want to hold an event, maybe next month. You may want to factor in, will it rain that day? You can use time series insights to know that particular day, whether it's going to rain or not. Following patterns from historical data. So what are some of those steps? The first step in time series analysis is to plot the data and analyze it to extract meaningful information. We plot the data to see how the data looks like. What kind of insights can we get from that data? So that's the first step in time series analysis. And we can do this using the R software, where we will get introduced to R software today. So you can, if we can have, say this is time, and this is malaria cases. Malaria cases. So we can plot the time series to get information. So if I plot this, so this is a time series plot. It's over a period of time. And so with this now, I can get some insights. I can understand some of the behavior of this, my data. For instance, here now we have, what do we observe here? What do we observe from this point to this point? There's what? There's an upward trend. There's an upward trend. What is trend? Trend is what? The upward or downward movements of the entity. The upward or downward movement. So there is an upward trend here. And then here there are no trends. It's stagnant here. There is no trend here. It's a bit stagnant. And then we also have, after this point, we also have an upward trend. There's a jump. It shoots. It also has, so you can plot your data. And just like I said earlier, in fact, it is wise that before you carry out any modeling work, any data-driven modeling work, the best thing, it is good for you to, first of all, visualize your data to see how the data behaves. It will give you insights on how best to do your work. So here, we have an upward trend, and then there's a stagnant part here. There's a trend here. There's also a trend here. Why there's a stagnant, there's no trend here. So you check your data, visualize it to see the components of those of the data sets. Can we go back to the slide now? So then you study the past behavior. After plotting the data and analyzing it to extract meaningful information, study the past behavior. For instance, how has malaria cases behaved in the past? If we know how malaria cases has been in the past, it will give us insight, to give us idea of how it will perform in the future. So we study the past. That's another step in time series modeling. Also identify underlying patterns and trends. When we identify underlying patterns and trends, you look at from plotting the data set, the time series data, you now check, are there trends in this data? Our time series data has some components: trends, seasonal patterns, cyclic, and all that. So trend, we said trend is what? How do you define trend? The upward or downward movements in the entity. So here we identify the trend in our plot. There's a trend here, upward trend. We also have here, we can also have situations where it is coming down. The cases, malaria cases is coming down. What kind of trend is this? This is a downward trend. You can also visualize, you can also identify seasonal patterns. What's seasonality? Prof defined it for us yesterday or today. What is seasonality? Who will remind us? What is seasonality? Peaks that are what? They are systematic peaks that occur at regular intervals. Systematic peaks. Seasonality is a systematic peak that occurs at regular intervals. For instance, if we look at sales of chicken, you will observe, if you plot the graph of sales of chicken, you will see that the sales of chicken will be peak at a particular point. Which point? Which month? Easter and December. You will see it. If you plot it, you will see that it will jump up maybe during Easter, and then December again, it will jump up for yearly like that. That is seasonality. Every year it is consistent, the same period, Easter, and then December 25, December, around that December period. So that's an example of a seasonal pattern. Systematic peak at regular intervals. It's consistent at regular intervals. What about cyclic? Okay, somebody has a question. Cyclic. What's the difference between seasonal patterns and cyclic patterns? Consistent but not, it's not regular, can be irregular, but we have peaks that are occurring, but maybe one peak can happen in say January this year, and then next year it is in March. The upper year it's happening in August. It's not regular, it's not at regular points. Exactly. So that's basically the difference between seasonal patterns and cycles.
I'm just imagining, should in case there are maybe disease outbreak in chicken, I think the graph will also fall at that season. That's what it just came to mind.
Okay, for If there are disease outbreak,
yes,
say in December,
to recap that, maybe December,
that it will affect. Are we?
to affect sales.
Okay, has there been a such time that this December there were no chickens? People wanted to buy chickens, and then, huh? Okay, so but then it might so it will now depend on the level of the peaks. It might not be as for that particular year, it might not be as high as it used to be. But then you also see a peak in the sales of chicken at that particular point in time. All right, so we also, okay, so I was asking what's the difference between cyclic and seasonal patterns. So for seasonal patterns, we say it's regular, at regular intervals, at regular periods. Whereas for cyclic, it's not regular. So that's basically, so are there cyclic patterns? So now these are some of those components of your time series. And when we want to carry out time series analysis, some of these components are what will help determine what kind of the type of test we need to carry. You check whether that time series data, is it stationary, is it non-stationary, because most forecasting models, for instance the ARIMA model, works on the assumption that the data set is stationary. So when we probably in the course of this lecture, we will talk about some of the aspects like stationarity, and then how to different types of models such as the ARIMA and the SARIMA. So then this next step is to use past data for forecasting. You use past data for forecasting. Remember we said we plot the data first, study the past behavior. There's a way you can know the future from the past. If you look at it's possible for you to know the future of somebody. You know that this person, from his behavior, from his today, from his yesterday, the patterns he has been you can predict that this person will not, except there is a drastic change, something drastic. And that is why in Nigeria too, except there is a drastic change, it is not likely that things will get better, except something drastic happens. Exactly. So you can use, study the past behavior to use it to predict or make forecasts into the future. We use past data for forecasting. I said the goal of time series analysis is forecasting. That is, we want to estimate how the sequence of observations, how will it continue into the future? How will time series, so we said the goal of time series analysis, the ultimate goal is that we want to be able to make forecasts. Like I mentioned earlier, man has been in a quest, wants to know tomorrow, what will happen tomorrow. Like we did a study recently to know the mpox incidence and mortality rates in Nigeria for the next 14 months. And we're able to see that in the next 14 months, mpox incidence in Nigeria is going to be around monthly we'll have just about 13 cases and 0 mortality. So with time series analysis, you can forecast into the future. 2 years, you can forecast to know what will happen. That's what we'll be going through in this particular course. And after this, we would be introduced to R, and that will set us to start applying our time series using R to do our analysis and all that. So thank you for listening.
All right, thank you so much, Mr. Shun, for that beautiful and brilliant presentation.
Thank you.
So, of course, like he told you, something great is happening. I told you already, by God's grace, and we are setting up properly already. So now, because of our time, I will take questions, but I want to minimize questions. So the first 3 questions I will be taking. Okay, so one is already up there, 1. So if you have time, I will take next, I'll take more. 2 and 3. All right, thank you so much. Can we have those? It's not the same. You know, it's not the same course.
This is our, the next class is, okay.
Okay. Thank you for your presentation. Please, in a gentle way, can you explain briefly the difference between statistical modeling and mathematical modeling?
Okay. Thank you. I didn't even see. So basically what we are doing here is statistical model. What we did just now is statistical modeling. Statistical modeling is data driven. Statistical modeling is what? Data driven. If you don't have data, you cannot do any statistical modeling. Whereas mathematical modeling, we have mechanistic models, just like the one Dr. Hafiz took us through just now. Mechanistic model, it talks about the transmission process, the mechanism behind the disease. Statistical modeling does not factor in the mechanism of transmission, but mechanistic model, mathematical models, compartmental models looks at the mechanism. You see, we looked at how transmission moves there's a transition from susceptible when it gets in contact, disease relevant contact with an infected person. And then so there is we're looking at the transmission dynamics. After the infectious period, that person recovers. We consider the biology. Like Prof mentioned that before you can do mathematical modeling, you must understand the biology of that particular disease. If you don't understand, because you're going to factor the understanding of the biology of that disease is what will determine your model, is what will help you to develop a mathematical model. Whereas statistical model, you don't need those, you don't need all those mechanisms. You just need your data, and then you carry out the analysis you want. I hope that is clear.
All right. Thank you for that lecture. Thank you. You started with telling us, and then towards the end, there is this mixture of words. I want clarification. We talked about time series, forecasting, and then when you were trying to give an example of somebody's behavior, you went into predictive. Are they similar? Are they the same thing, or they are different? Predictive, and Prof has been speaking about predictive modeling. Now we know it's forecasting, so can they put some more light there?
Okay.
Thank you.
For forecasting refers to, you are looking at a maximum of 2 years, between 2 years, maximum of 2 years. You are looking at, you want to forecast into the future, but in a range of 2 years. And that is why most times statistical modeling, once you try to do beyond 2 years, it's not very reliable. So forecast in this sense now refers to, you are looking at a period of 2 years. But then for prediction, you are looking beyond 2 years, say up to 5 years, and then there's also the projection that goes beyond 10 years. So forecast looks at just a period of 2 years. So that's basically the difference between forecast and prediction. Okay. Maybe I didn't get.
Go ahead and express your mind.
Yeah. So I don't think it's delineated by years.
Okay.
I don't think so. Just forecasting, to me, I see it more as data driven. Basically data driven. You can actually do some level of prediction without necessarily having some data. You can use insights. Just like you gave an example, looking at somebody's behavior, you can talk about, you are predicting the likelihood of this based on some background information. We have not really employed data. So
the background information.
Yeah, so I'm trying to see, there is a thin line. They about the same thing, but I think there's a thin line that we need to be able to identify.
Okay, Prof wants to say something.
Okay,
Or
okay.
maybe I would,
Okay, maybe, so for predictions, you need data to also make predictions. You are saying you don't necessarily, you use data to make predictions too. All right, but Prof should.
Okay, yeah, so we have different levels of all this. We are forecasting, nowcasting, we have nowcasting, we have forecasting, we have prediction, and we have projection. So when you are saying nowcasting, you are saying like during COVID, people want to know what will happen within the next 2 weeks. So and then I have a data, and then I can tell you what will happen within the next 2 weeks with my data. And then after that, I want to know what will happen within the next 1 year. We can do that with forecasting, like time series model and all that. And then we want to know what will happen within the next 2 years. So now for forecasting, like he said, you know, you can do that. Now all these asks in the class I had this afternoon, there's a part there that we are going to come about forecasting, prediction, and projection. All of them needs data. You cannot predict without data. So it's like you are extrapolating from the given, from the known to the unknown. So when you say prediction is within 2 to 10 years, and then you attain projection is 10 years and above. Okay? Thank you.